talk. So now we move to our next speaker, Vartika Pandey. So who will be speaking on the pencil code GUI visualization tool and new additions to PC_get_quantity. So Vartika,
Okay.
yes.
Am I audible?
Yeah.
Okay. Hello everyone, I'm Vartika Pandey and I am doing my PhD with Philip in University of Graz. Today I will be presenting the I will be speaking about the pencil code GUI visualization tool, and most of my talk I would prefer it to be interactive because I would be sharing my screen and telling about the tool and demonstrating that, and it will include how to call the GUI, how to use it, what are the important features of the GUI, and what is the code for that, and how, if you want to make any changes, you can make to that. And the next part, I would be talking about PC get quantity, and this is the tool from where you can add the parameters to PC GUI visualization tool, and the steps to add how to add if you want to add any parameter to the PC get quantity. So these slides are more like a summary for that, but I think I will start with presenting my screen and directly demonstrating what I'm trying to do, what I'm trying to tell, and then we can come back to slide because these will be some important points to remember. So can you see the terminal screen?
Yes.
Okay. So you have to go to the pencil code folder. You have to load your pencil code environment. You have to load the ideal. You have to load out ideal in your terminal, and then you go to the sample which you want to visualize. There are like a lot of samples in the pencil code. I am choosing the corona sample. You can choose any sample and you can visualize that with the help of our GUI tool. So I will go to samples and then corona. So you have to make sure that you have the data directory here, and I've already run it. I've already done the run. So I have the data directory and all the var files. So now I will open ideal, and for calling the visualization tool, the command is .r pc_GUI, and you just put it and this will open. One second. Now you have like various parameters. This is like a pre-selection menu for the parameters that you want to visualize. So this run is run for a small time, but if you have a large number of bar files and a large number of snapshots, then you can maybe select all of them, or you can apply like we have an option like I can select every second snapshot, or every fifth, or every 50th. If there are a lot of snapshots, then you can select if you want to select all of them, or you want to select like every 10th, every 20th, like that. Currently, I will prefer to select all of them. Now, you can, there is no crash right now. Otherwise, you can also select if you want to include the crash file or the var.h5, which is the last file. So yeah, I will just remove it because this is the last file. I only want the var files. Now there are like various quantities and there are various parameters that you can select from. All these parameters are coded in the PC get quantity code. I will talk about that later, but all the parameters which are coded there, and there is a way to connect them to the PC GUI tool, and we have a vast range of parameters that you can select from and analyze. So this is the default selection. So maybe you can, if you want, you can set, you can press control and you can select current density, or you can select ohmic heating rate. So you can select all the parameters that you want. And then we have overplots. Overplots is like if you want to see the flow of something, then you can select the overplots as well. And there is like these selections that show the dependencies. Like if you only want the parameters with velocity into them, then these will be this. If you only want with density, then these are. So if you want to load like less data, then you can select from here. But right now I will show all of them. You can also select, like, if you want to load the full 3D data, or if you want to load a slide at some height, so you can select it from here, and you can load maybe a YZ slice, a XZ slice, or if you want a sub volume of the full 3D volume, you can also select the start and end from here and load it. But I'll be loading the full 3D data, but there are options if you want to load only a specific file, so it will take less time and less data like that. So, and you can scale this tool according to your screen size. So right now it will be working, but if you want, you can scale it also, like you can add some quantities here and press enter. So you can check it according to your screen size. This works for me. And then it will show you how much of data will be loaded. And this tool time series, I will explain later. So I have made all my pre-selections for this tool. And if I now press OK, it will take a few seconds or more to load it. And then we can see the main menu.
So Vartika, this will work for other data files other than HDF5?
Yeah, it will work for all data files, all the var files, it will work for all of them. Yeah, if you have a output in var files, then it will work with all the data formats. So here we see the screen. I will just remove this absolute scaling. So there it is temperature. Now this is var 5.h5. So you can go back into time and analyze like var 0, var 1, var 2, and like you can even play a movie, like it will just show the evolution. Right now I have very less data set, but if you have a large data set, you can play and you can check the evolution, how it is working. So um, yeah, you can like there are a lot of options which you don't have to write any code for. You can do directly, like you can select logarithmic plot, or you can select if you want to scale your data to absolute values, it is absolute scaling. You can have the power spectrum, like it doesn't show anything in this, but if I go to like velocity, and yeah, then you can choose a lot of options from here. It is var 0. Yeah, 1 second. Yeah, you can choose like power spectrum. And like if you have a non-equidistant grid, then you can also use this quantity d-stretch grid. And here, like if you have a non-equidistant grid and you select the d-stretch grid, then the quantities will be like every pixel will represent your physical size. So we have a lot of options here which you can do directly for this data set. Like if I show this magnetic field Z, yeah, I've shown you this, that you can just move front and back in time with this tool. Also, like here, this is the Z, like this is the height along X, Y, and Z direction. So if you want to see this quantity at the photosphere at the lower value, so you can click here. Hello. Is it okay? Is there a question?
Now
Yeah.
this bottom row, what is being shown in that pictures in the bottom row? Are those the radial profiles or what is it?
Yeah, these are the plots like for the quantity. Like if I choose the magnetic field Z, then you can see it along this line here. Like you can check it at different points. This is height with X, this is height with Y, and this is like the Z cut, the top view. So if I want to see the photospheric data, I will click here and you can see, you can also move it from here. Like this is the pixel value and this is like the value in SI units. So if I want to go to the lowermost point in the photosphere, it is here. If I want to go to the at height, so I am at height here. You can see from the crosshairs in the X and Y direction. So you can directly point on the screen to go to that, or you can maybe use this tool for that. You can like easily swipe through different heights. So this represents that. Also, you can see the average profile, like we have X, Y, Z, and radial. So like I'm talking about say temperature here, and I want to see the average profile of temperature in any specific direction, then you can see that the dotted lines represent the minimum, the maximum, and the connected lines will show you the average profile. And you can also subtract the average profile so as to see the evolution more clearly. So I have explained hopefully these tools here. these hairs as well. Now you can select like these are the quantities that I pre-selected from that menu. You can select whatever you need for your simulation or what you want to visualize, and all of these quantities are added from the PC Get quantity tool. Now, like if I go
But
to,
does it also calculate the derived quantities like vorticity?
you will have to check if these quantities are added to the PC Get quantity, and if they are not, you can add the code to it. Like I have that I wanted to use and I wanted to visualize, and I will show that also. How can you do that?
No,
So-
for example, if I want to visualize the vorticity, then do I have to, store it as an auxiliary variable, then output the what file? Is that the way I should?
Yeah.
Okay.
Yeah.
So even averages, I think, has been pre-stored, right? It is not being calculated in the
On the fly.
GUI.
Yeah,
The
you can.
averages is also from the pencil code, not from the var files, but they have been stored as some averages.dat or something, right?
I'm sorry, I'm
Yes.
not sure about.
Yes.
Yeah.
Problem is just that the tool is not for displaying the averages, so that would be a separate tool then.
Yeah.
Okay.
Yeah, and you can also select like there are a lot of there are options like above this magnetic field, you can overplot the magnetic field lines, like which direction they are going. Is it going outwards? Is it going inwards? You can select the vector length, or you can increase it or decrease it, and then you can show how the magnetic field lines are varying. Now, if I remove it, you can like streamline, like it is like magnetic field line tracing. Like if I want at this point, I want to trace a field line. For that, I have to choose first magnetic field here. Then this point, I will add a streamline, maybe in the Z because it will be more clear. So I select min max. I can add maximum of 64 lines, but right now maybe I will show like 16 lines or something. And then if I add it here, so it will show how the field lines are added. If I want to add a field line at this point, I will click here and I will add, maybe I will add just one. So I hope it is visible. So you can follow the magnetic field vector and you can add the streamlines as well using this tool. Now there are some tools here as well, like save the settings, play the movie that I already showed. There is a tool slicer. So like I agree that this could use some more corrections, but it is not very efficient to visualize. But yeah, if you change the setting, it will show you the slice that, yeah, like, yeah, but you can see it from here as well. This needs a little bit more correction from our side, but you can save the movie or you can quit. So these are the here. Also, like if you want to visualize this between a specific range, you can set it from here, the minimum and maximum value. Like currently it is at like the min max value, it is scaling between them. But if you want to select like minus 0.05 or 0.05, you can do that and set the range according to you. Now, like if you are visualizing the temperature and there are various want that you can visualize temperature like this. So yeah, like this. Also, if you want to visualize the velocity, so we have the velocity here, and if you want to visualize it in what is happening, yeah, set min max. I changed the range actually. So if you want to visualize the velocity, you can view it in blue, white, red, and like if you can also put the velocity over plots to see where is the evolution going. So these, yeah, you can jump to the, like if I remove this, from here you can jump to the minimum value pixel, you can jump to the maximum value pixel. The crosshairs will move to that point and you can see the value also. Like if you put the pixel at, like if you put the crosshair at this point, you can see the value at XYZ position. You can see the value at XYZ position here where you selected. And you can also see the plots like along that line in the downside. So I think I have shown most of the parts of this PC GUI tool. If anybody has a question, they can ask it.
So can we save file in this Vartika? Like,
Yeah, you can save here. Like if you want to save a plot, you go to average profile, you can save the plot from here. And there is also this time series analysis. So all the quantities, we were viewing them with the height, but if you want to view it with the time evolution, you can just click at the quantity and you can save them. Also, these quantities, if you don't understand what they mean, we have it in the manual. So they are from the print.in file, and all of these quantities, their explanation is here, what they are. So yeah, where is that? Yeah. So these quantities are here, and you can vary it with the time, and you can also save the plot everywhere.
but
And
there seems to be no labeling to this plot. Is there labeling?
No, there is some.
there is Z and there is this, so you can save the plot from here. Also, these plots, I think, like you can save the movie, you can save the plots, you can save the average profile, but I think you'll have to take the screenshot for this. I don't see a option, but yeah, it is like that. So
And they will be saved together with the images. So you will have an image of the lowermost plot and the uppermost plot if you click save there.
yeah, save here. Okay, then I think I will close this tool. I'll close this file. So this was the PC GUI. You have to load the pencil code environment, you have to load ideal, you have to go to your sample location where data is, you have to write the command .rpc GUI. The GUI visualization tool will open, and then you can select the quantities that you want. Also, for better understanding this for this code, I will show the code files. So you can go to pencil code, you can then go to ideal, then you can go to visualization GUI, and then here are all the codes that have been written by Philip for this code. So if you want to see how the time series works, so for investigation and analysis of time series, this is the code. So for like emissivity, for access profile, for like slices, for 3D slices, for viewing and comparing 3D slices, we have the specific code here. And if you want to go through that, so it is available here in the pencil code, ideal visualization, and then GUI. Now I would like to talk about PC get quantity. If you have just one quantity to visualize, like if you want to visualize the temperature at some point, so, and if you do not want to open this whole thing, you can, so we have in pencil code ideal, we have PC get quantity here. So you open it, and yeah, these are the quantities that are available. And more than that, there is also a file called PC check quantities. So if you go in PC check quantities, these are all the quantities available to view in the PC GUI and also in the PC get quantity here. So for viewing anything in PC GUI, it need to be added to PC get quantity and then to PC check quantity. And I will tell that in a moment. Right now, I just want to show the code PC get quantity. It has all these variables. It has all these options. Like if you want to include the ghost cells, clean up vars, then it is how it is called. And there are like various examples which are very easy to understand. I will also demonstrate one very simple example on how to call PC get quantity. And the advantage is all the output that will come from PC get quantity, it will be in SI unit. So you don't need to convert and you can use the plots directly. So it is like that you can load a sub volume, you can load a slice, and this is all explained here how to do that. So I have written a very simple code, like if you want to call a quantity from PC get quantity, it will be like Z. I want to take the temperature, then it will be like temperature, PC get quantity, and from PC check quantities, we can check like how the temperature is called as temp, the logarithmic temperature is called as log temp, the like how the quantity is called, and then you can write here in inverted commas and from which var file you want to load it. And then simply I just plot it. It is a very, very basic code. I just wanted to show how PC get quantity work. So if I go to a run, I open IDL and then I just call that function. So you can see that we have a temperature plot here. logarithmic temperature plot with height and in SI units. So that is why, like, if you want just to load one quantity or you want to load one profile for one var file, then PC get quantity is a very easy tool to get it in SI, and you can directly use it for your plots. So also, if you like, not all the quantities that you will need will be available here in PC get quantity. Just give me a moment. Yes, so all the quantities will not be available here. So you can add your own quantities as well. Like if you want to analyze some quantity and it is not available here, so you can check that there are some cache quantities which are available to us, and using these quantities you can write your code. Like I have added some things. I will show you how to do it. Heat. One moment, I'm sorry. Yeah, I'm opening the wrong directory. It is here. So you can add your code as well. Like I wanted to analyze heating or cooling due to compression, and like I wanted to analyze viscous heating. So I added the code for it here, and like some quantities which are available in cache, you can use it like PC compute quantity. Other quantity, you can like use the divergence, and like you know the formula for it, you can code it here, you can add it here. So if you want to analyze some specific quantities which are not available into GUI, because GUI, like I find it very useful for me to directly use that. So I added like viscous heating, compressional heating, heating cooling due to conduction, radiative losses, and heating and cooling per particle, and heating and cooling due to Newton heating. So I added this code here. So for adding it to PC GUI, you add a code here, then you add it to the list of available quantities here. At the that also I will have to open from that version, which is mine. Yeah. So one second. Yeah, just one second. Yeah, so this is like the usual list of the parameters which are available in PC get quantity right now. Then you can add yours here, and like the quantities that you add, and then you have to add the list of dependencies, like what are these quantities depending on, like what the dependencies of these quantities, and you can add it here. And these quantities, if you added these 2 points, they will be added into the PC GUI tool and PC GUI tool, and it can be loaded from there. But like you have to check these if the results are matching or not. What you can do is you can directly output from var files and then output from your code and compare if they both are identical or not. And if they are, then you can add it. And you have to make sure that like this is you have to make sure that all the quantities that you output are in SI, because both of these tools, PC GUI as well as PC get quantities, have their output in SI. So important things to remember for the PC GUI tool is that your output will be in SI units. If you want to set scaling beforehand, even not in the tool, then you can set scaling like this as well. Like if it is 444, you can just give like this. If you want to, because you might need to adjust the tool according to your screen and then call it. Also, when you choose a streamline, or if you want to do a field line tracing, before that you should choose the overplot. Like you, for magnetic fields, you can choose the overplot and then close it, and after that you can follow the magnetic field lines on that. For PC get quantity, this is the calling sequence. This is how you can call it, what it is named. You can check it in PC check quantities. For the code, it is available here in pencil code ideal PC get quantity .pro. You can check it, and yeah, you can add your own quantities because not everything will be available here. So important things will be your output will also always be in SI units. the quantities in PC GUI are added from PC get quantities, and yeah, you can compare, like you can directly compare a plot from the GUI tool. And if you want just to use one plot from one var file, you can use PC get quantities. That is a faster way to do that. So these are the quantities that I've added. I've also shown you how to add the quantity, like parameters to PC get quantity. So yeah. So I hope, yeah, that is okay. If you have any questions, you can ask me.
Yes, please go ahead if you have any questions.
Yeah, so Vartika, I had a question. Yeah, so this, you showed this quantities HR, whisk, or, something like that. So they are what, are they calculated after, I mean, in post-processing, or they are some variable in your var file? This HR, viscous, is it a variable in the var file, or it is
Like,
some?
you have some already existing quantities here, like gradient of row, temperature, all these, and then you can calculate it, like gradient of temperature, you can calculate it here, or HR whisk is like, it is somewhere here, so you can.
So you are calculating these quantities in post-processing from this row, temperature,
Yeah.
all these velocity, all these quantities. So these are derived essentially, right?
Yeah. So this is here, like you can calculate HR ohm, and you can write the formula, you can calculate it here, and then you can visualize it in the tool.
Okay, yeah. Thank you, Vartika. Very nice work.
Any more questions, anyone? Wait for lunch.
We needed two, so
Yeah.
it is in 45 minutes.
Yeah.
Stock.
Yeah. So I think we are at the end of this session. So thanks to all the speakers of this session. And we will reconvene at 2 o'clock Indian Standard Time, which is around 45 minutes from now, with the talk by Jon. So see you then at the same link.